Hello, everyone. Welcome to the Lyceric Papers. Today, I would like to continue with the second electromagnetic wave, and I would also like to then go back to some of the things I said in video 1 and explain them a little bit further or recap on these statements. So going back, again, the speed of light is irrespective of the speed of the emitting body. So as the body, in this case, the particle in this blue circle, emits the light, it has a certain speed we'll call V1. And of course, the light has a speed of c, which means that there is a delta V, which is c minus V1, if both the particle and the light continue on that same trajectory. But it'll never be that c plus V1 is something greater than c. And this is the fundamental statement that comes out of the 1905 papers of Albert Einstein. So, why does this happen? And the very first simple explanation is as these charged particles, which I will call atoms, spin off the spinning electron, they will naturally take the shape of a helix. And as they are flying in this helix, they start creating their own magnetic field. And this magnetic field basically creates the force that balances the centrifugal force of these charges. Again, these charged particles have a charge, Q0, and a mass, M0. And as they now create their self-sustaining magnetic field, this packet flies off in a consistent speed. And the reason for this, and I have simplified this basically by saying, okay, the fundamental force, magnetic force, comes actually out of the electrostatic force, and thus I can use the electrostatic force, the math of the electrostatic force, to balance the centrifugal force. And so on the right-hand side of the Formula 1, I have the centrifugal force of the mass of the atom, m0, times, of course, the velocity square divided by the radius of the flying particle, and the flying particle in this helix. And of course, that is counterbalanced by the electrostatic force, which is the charge times its potential, divided, of course, again by R. And as we could see, R cancels out so that we have V square fundamentally divided by the charge, V square equals the charge divided by the mass. And as the potential in this, the potential of the charge is pretty much the same, we have a constant because the charge is constant, the mass is charged, and the potential of the charge is constant. So basically, V square becomes C square. And this is the fundamental, simple reason why the speed of light is constant irrespective of the emitting body. There is another way to look at this, and that is basically each atom contributes to its own magnetic field in the same strength as it would, of course, an electric field. The lambda of the maximum Rydberg frequency, lambda r, inserted in the equation 2 will give you the clue that each atom contributes to the magnetic field with one constant value. So what happens here is that the more atoms you have flying in this helix is basically n times the charge force in equation 2 on the right side. So as n increases, the only actual thing that then can increase on the left side is if lambda decreases. And this is fundamentally the reason why the more atoms are flying in this helix, the more the lambda has to go down. So basically, as the frequency goes up, the wavelength gets shorter so that the equation balances out. So one way of destroying such a self-sustaining wave is that you would have directly a very strong magnetic field that would basically be contrary to its own self-magnetic field, and thus the centrifugal forces would not be held in place, and then the each individual atoms would start basically flying off the handle. And here in this example, I have given you the value of the force that is needed for a 10 gigahertz type of a electromagnetic particle wave. So today I wanted to go one step further and also deal with the E equals mc squared. So the fundamental issue here is, as you can see, as the atoms are flying in this helix, they have on the y-axis, of course, the speed of light, c. But on the x-axis, they also, if and when this helix is symmetrical, also c. So fundamentally, actually, the atoms are flying at a √2 times c. But as you remember, the fundamental energy, or a kinetic energy, is mv squared half. So if I actually put in that the m0, which is the mass of the atom, is then √2 times v squared half, which then, as you can easily see, √2 to the square is 2, and so the 2 and 2 cancel each other out, and I have m0 v squared. Since v squared is a constant, in this case c squared, of course, basically then the energy becomes m0 times c squared. There's another little change to this. Of course, as the energy of the electromagnetic wave increases, the only way that this can happen is the more atoms that are flying in this helix. So the simple form is that actually the energy of this helix is n times the mass to the square of c. And this is the reason why the Planck energy formula works, because fundamentally the only reason that the energy increases is that there's more atoms flying in this self-sustaining wave. It is actually not that the mass is increasing in terms that the mass is mysteriously increasing. The only reason the mass is increasing because more atoms are actually in this packet of light. So as you can see in the equation 6, the energy is n times the fundamental energy of such atom flying in this helix. So fundamentally then, mc squared equals then the Planck quantum. And as you can see, n is directly correlated to the frequency. And this is why you could postulate that the Planck quantum is actually has the wrong dimension. So actually the Planck quantum should be ampere second volt instead of ampere second volt second. And this makes a lot of sense because now ampere second volt is actually very clearly energy, and that's really what the Planck quantum should say, is that it's an energy unit and not a energy times second unit. So I'm like to stop here with this fundamental postulation that the frequency equals the number of atoms flying in this helix. So thank you for listening in, and I hope to see you then on my third video that goes more into details and uncovers further aspects and consequences of this second electromagnetic wave, which I also refer to as the electromagnetic particle wave. Thank you for listening, and hope to see you back. Bye-bye.